Today we're gonna have our Declaration Day event. Our first speaker is Braden. He's one of the co-op students, and he's gonna graduate this year. I think he has a very lovely keynote speech for us prepared, and we'll just get started with his speech.
All right. Hi, everyone. So my name is Braden Bartoszewski, and I'm a mechanical engineering student here at Lassonde. And like Bruce said, I'm going to be graduating this year. So today, as a keynote speaker, I'm going to talk to you a little bit about mechanical engineering and my experience of it here at Lassonde. I hope that I can provide you with a little bit of insight as to what the mech department means to me and that it helps you in choosing your major. A fun fact about me is that I was actually a part of the very first class of mechanical engineers at Lassonde back in 2014, which means I'm at the top of the seniority list, not only of students, but faculty members also. It also means I've been through 2 strikes and a pandemic now. So to say my 7 years here have been anything less than interesting would be a lie. Unlike all of you, I entered Lassonde directly into the mechanical program. I had no idea what it actually meant to be a mechanical engineer, but I knew it was what I wanted to do, or so I thought. After first year, I thought the last thing on earth I wanted to do was be an engineer. I didn't have any interest in calculus, and I knew I didn't want to be an electrical engineer, so I didn't want to have to take those courses. Luckily for you, you're halfway through your first year, and that means before you know it, you'll be able to focus on the courses that matter, the mechanical ones. Now, I may not have had any idea of what a mechanical engineer was when I got to school, but hopefully I can give you an idea of what it means to me now. Mechanical engineering is easily the broadest field of engineering, which is a blessing and a curse. It makes it hard to define, but it also means that there are a lot of opportunities to find an area that you really like. I like to think that if there's something that moves, it was stamped by a mechanical engineer. This means everything from the pencil you write with to the airplane that we're all dreaming of boarding once this pandemic is over, and everything in between was made possible by a mechanical engineer. Engineers are problem solvers by nature, and mechanical engineers take this one step further by using their understanding of mechanical principles such as thermodynamics, motion, energy, materials, and more, and apply it to real-world problems. They design, analyze, manufacture, operate, and maintain these mechanical products and systems. Everyone always has a problem, and it'll be your job to find a solution. Some of the disciplines within mechanical engineering include automotive, aerospace, manufacturing, robotics and automation, thermal and energy. And there's so many more. I think one reason I was drawn to mechanical engineering was that I had an interest in cars, and it seemed like a good way to get to work in that industry. I've personally had the opportunity to work within the HVAC and automotive manufacturing industries. And for those who don't know, HVAC stands for heating, ventilation, and air conditioning. And this required a strong understanding of thermodynamics and energy in order to design adequate mechanical systems. This was all directly related to the construction industry. And in the automotive field, a knowledge of manufacturing techniques and CAD design was really important as I was working on die-cast design. You can see that these are 2 completely different areas of work, but they both fall under the mechanical engineering umbrella. As I mentioned, coming into school, I thought that the automotive field was where I wanted to work, but I actually found that the HVAC industry is where I ultimately want to be, and I've accepted a job offer to work in that field. So I think it's important to be open because you never know what's going to come up, and it might catch you by surprise. I found that the courses I took here were directly related to the jobs that I've had, and it truly set me up for success. So as I mentioned earlier, I've been at Lassonde for a long time. I started school before our beloved Bergeron building even existed. Hopefully soon you guys will be able to get in there and see what I'm talking about. Part of what drew me to Lassonde was that I was getting in on the ground floor. I was lucky enough to get to grow with the school and be part of shaping its future. Clearly, I wasn't the only one who believed in the school because they were able to attract some of the best professors I've ever had the pleasure of knowing, some of which you'll get to hear from shortly. In 2014, the first class of mechanical engineers had somewhere along the lines of 60 people in it, if I'm not mistaken. Through the hard work of the amazing faculty here, the mechanical engineering department has been able to grow this substantially while still maintaining the feel of a small program. Every year I've been here, the department has managed to keep bettering itself, offering more and more to the students. They've consistently expanded their areas of research, and they are always leading in innovation in their many labs. In 2014, the mechanical program became accredited, and I had the pleasure of watching my friends graduate and enter the field. I still keep in touch with many of them, and they've all gone on to do different things. But one thing remains the same. The mechanical engineering program set them up to succeed in their careers. I've been on a long journey to get to this point, and there's no doubt about it, this has been the hardest challenge I've ever faced in my life. But I wouldn't change any of it, even if I could. I have a few pieces of advice I wish I knew when I was in your spot, as it may have saved me a few years of school. Get involved in any way you can. Sports, clubs, engineering challenges. I know it's harder right now given the pandemic, but it's a great way to meet new people. And there's more to life than just schoolwork. Take the time to get to know people in your classes. You're all in the same boat, and you will need a support network to get you through your degree. Whether it's working on projects or studying for finals, it's invaluable. When your prof tells you it can't be done the night before, they're warning you and not challenging you to try it. It might fly in first year, but it won't as you progress. And mechanical is by far the coolest discipline. Anyone who tells you otherwise is simply wrong. With the help of the mechanical engineering department here at Lassonde, I was able to find my own path. They've given me the skills to succeed not only in work, but in life and to pursue my own goals. For instance, I rebuilt a 1987 Yamaha motorcycle, and there were countless times I relied on the things I learned here at school. From problem solving mechanical issues to troubleshooting wiring problems, it was all possible thanks to the understanding of these systems that I'd gained here in my classes. There's a quote I like: fail early, fail often, but always fail forward. Unfortunately, I may have taken that first part a little too literally at some points, but the mechanical department always made sure that I failed forwards, and I have no doubt that I will be a better engineer because of it. You have a great opportunity here to join the mechanical department, and I know that by the end of your time here, you'll thank yourselves because it's one of the best choices that you could ever make. Thanks.
All right, thank you so much, Brayden. I'm sorry that we're not in a actual event. Otherwise, people would have been applauding by now. Next up, we have the professors panel. Joining us will be Professor Sadek, Professor Roger Kempers, Professors Malinka, and Professors Reza Rizvi. Please turn on your camera and we should start the panel.
Was there a certain order or just anyone just?
I think you should go first, but
Okay.
we don't have an order in mind. It's just a very informal talks. So
Even as my name is Hussam Sadek. I'm an associate professor in mechanical engineering. I'm also happen to be, at least for this year and last couple of years, the undergraduate program director. So if you have any question about the curriculum, the courses, prerequisites, progression of your degree, probably I'll be the right person to talk to now and in the future, next few years. It's very hard to follow Braden's speech. Did a good job talking about mechanical engineering. You're going to see me in the first, I will be one of the, probably your first lecture in second year in thermodynamics course. You'll see me in multiple courses in thermodynamics in second year, heat transfer in third year, and capstone in fourth year. My research is basically as obviously thermofluids and heat transfer. And yeah, and that's it. I hope I see you all next year. Roger?
Thanks, Hassam. Ruzbai actually prepared slides. I came prepared. Is that possible to share them?
of course, I'm just going to make you co-host, and you can start sharing.
Now you are making me look bad.
Oh, that's okay. That's fine. Well, good afternoon, everyone, and thanks for joining, and thanks to Braden again for that intro. I went ahead and prepared a few slides for Declaration Day, our COVID edition of it. So I'm Professor Roger Kempers. I'll give you a bit of background about myself and then tell you a bit about the teaching and just to sort of set you up. So I studied at McMaster University. And funny enough fact, Professor Sadek and I actually did our master's degree together in a strange twist of coincidence. So it's a small world. And I specialized in thermal fluids as well. We worked in the same laboratory. So thermal fluid science that encompasses thermodynamics, fluid mechanics, and heat transfer. So that's the area I specialized in, and that was me in my younger years when I didn't work when I didn't work in my home lab in the basement, I worked in a real laboratory. So after graduation, I went to industry. I come from the industrial world, and I began my career after my master's degree in Ireland, where I was working for telecommunications companies the whole time, and developing cooling technologies for high-powered electronics, especially sort of lots of wireless technologies. You've seen these antennas on tops of towers and buildings, and they're connected to a bunch of high-powered RF hardware and so on that needs cooling, much like any electronics, like your laptop or computers and so on. And so it was developing technologies to kind of cool this stuff more effectively. And it was during that time that I did my PhD at Trinity College. So I was kind of doing this sort of in an industrial slant. So since moving to York, I still continue doing my heat transfer research. A bit of a flavor of different things here. I'm especially interested in where heat transfer intersects with additive manufacturing in terms of what we can potentially do in terms of making heat exchange technologies and so on, either with polymer composites or metal powders. But I'm also particularly interested in two-phase heat transfer, boiling heat transfer, and thermosiphons and heat pipes and so on. And you can see a few other things here. So I keep my work very applied, and I still do actually a lot of sort of industrial sort of R&D and technology development with companies and so on. And there's a few things here just to give you an overview. In terms of teaching, I've been really fortunate, and it was really nice to hear Braden say those nice things about the courses and some of the things. And I think there are some really special things about mechanical engineering and in the courses. One of them is Mech 2401, engineering graphics and CAD modeling, where you develop your sort of technical and graphical communication skills, your CAD skills, right, which are super useful as you go through your career. 3504 is our thermal fluids laboratory, and this is where you take all of the concepts and knowledge that you've learned in fluid mechanics and thermo and heat transfer and really apply them to hands-on experiments and so on. And then finally, last but not least, certainly is I've taught, or I teach Mech 3401, our third year mini design project, which this is where you really get to apply your sort of technical skills to a real world sort of design problem. You've begun doing this in first year in your Eng 1000 sort of courses. In second year, you have mini design project 1. And then this is the third year version of this. And every year it gets a bit more complex and more involved. And I think really sets up well the students for their capstone project in their final year. And I think this sort of thread of design, I think, is really key to mechanical engineering and really important, and one of the great things about our department. So with that, I thank you for coming and thank you for your attention.
All right, thank you so much. I think Professor Milanka is next. Professor, do you have a presentation prepared, or is it
Yeah, I have some slides as well, if that's okay.
All right, I'll give you. Here you go.
Okay, just a second here. Okay. Sorry, just give me a second here. Okay, share screen. There we go. Okay. So hello, everyone. So my name is Garrett Malenka. I'm also an assistant professor here in the mechanical engineering department. So just a little bit about me. So this is just kind of the contact information if you're interested in some of the work that I do. And there's a nice little picture of the Bergeron building, which we haven't been able to see all year. So just in case we forget what it looks like. And just about me, so I did all my degrees in Edmonton. So I'm an Edmonton boy, born and raised. I started here at Lassonde in 2017. So I've been here for about 4 years now. And kind of some of the things that I've taught in the past include things like a biomechanics class that I taught back in Edmonton. I teach Mech 2301, which many of the students will tell you is kind of one of the hurdles you have to get over in second year, but it's kind of one of the fundamental mechanical engineering courses. So I've taught that 4 times now. I've also taught Mech 2302, which is the dynamics course, which builds on some of the physics classes that you'll take in first year. And then 3302, which is the continuation, kind of a mechanical or mechanics of machines. And then most recently, I'm also teaching a composites class, which is kind of my bread and butter. So it's kind of just giving you an idea of kind of my some of the courses and things that I teach. And just kind of on a personal level, some of the things that I do. Normally, you would see me in the gym at Tate and things like that. So I weight lift quite a bit, do a fair bit of 3D printing in both research as well as just for fun as well. So those are some of the interests I have, just kind of outside of engineering. I am human. I'm not just a professor as well. In terms of my research, some of the things that I do is specifically on what's called a braided composite. Which is one style of manufacturing, and this is an example of like a braiding machine that can make these composite structures. I also do a fair bit of research on additive manufacturing or 3D printing, and in the past during my master's, I also did some work on orthodontics, so braces, in varying kind of ranges. Some other things that you know, especially as you get into mechanical engineering, I'm quite happy to talk about any of this kind of research. I actively hire students as part of like the LURA as well as the USRA programs. So if you're interested in these types of kind of areas of research, it's definitely something that I'm more than happy to have a chat with you at especially as you get into you know, second, third, and fourth year mechanical courses. And just to give you some ideas, so these are some past LURA projects and USRA projects that some of the students have done. So basically second year and onward students have come into the lab and done a fair bit of design and testing as part of our group work. So it's kind of one of those things that as an undergrad, you can certainly become more involved in if you're interested in research as well as kind of learning more about different aspects of mechanical engineering. So with that, that's pretty much everything I wanted to talk about today. So thank you guys for coming, and yeah, hopefully we'll see you in second year.
All right, thank you so much. Professor Rizvi, do you have a presentation as well?
Yeah, Garrett and Roger were making me feel bad, so I quickly put together something right now.
Peer pressure works, right?
Okay, so,
Right.
so it's my bad because I went the first one. So next time I'm going last next time.
Right. So am I able to share? Okay.
Yes.
And sorry, I'm just, yeah. Okay. Are you guys able to see my slides? All right, awesome. So yeah, my name is Reza Rizvi. I'm an assistant professor in mechanical engineering, probably one of the more newer faces here. And yeah, like, you know, the reason I studied engineering is just out of curiosity. I mean, I love discovery, I love innovation, I love sci-fi, as I'll show. Like, so figuring that out is why I got into engineering. And you know, mechanical engineering, I feel like, is one of the most strongest disciplines, and we'll talk about that. Just a little bit about me. I am from the Toronto area. Like, I grew up here. I went to University of Toronto, did my bachelor's there and my PhD there. I bounced around a little bit after that, and then finally returned home. Right now with the quarantine, I'm here with my family. So my wife and 2 kids. So they often make cameo appearances in the background in my lectures. I, like Garrett and Roger mentioned, I also do research. I'll talk a little bit about that. But yeah, just, you know, you are what your experiences are. And I've been fortunate enough to be just, you know, going to different places and just exploring around. I really, you know, there's no place like Toronto, in my opinion, when it comes to, you know, innovation and higher education. And so I'm really glad to be back here. But having seen the systems in somewhat like United States and then also a little bit in Germany and stuff, we're really privileged with what we got here and what we're building here at Lassonde. So what research do I do? So to be honest, my background or my undergraduate was in materials engineering, right? And that's a little different than mechanical. But what you learn, at least talking with me, and what I find from my mechanical colleagues as well, is that mechanical is a jack of all trades type of engineering, right? Where you will not find a single field where there isn't a mechanical engineer involved, right? And so in that sense, by taking mechanical engineering, your horizons are really broadened. And in terms of the research I'm doing here in our department, right, it's all on nanotechnology and also looking at how we can make stuff lighter, make stuff stronger, how we can maybe make the next, next materials for our batteries. How can we make things that are, slip resistant, etc. So mechanical engineers are really like, having their hands in all of these areas, even down to the very atomic level of things, right? So a great picture I love to show, which sort of describes the research that I do, is that by manipulating properties at the atomic scale, you can get a great manifestation of macro scale properties, right? So here on this picture is a nice picture of a highly ordered paralytic graphite. And graphite is composed of single layers, as you may have learned in high school chemistry, right? Of carbon atoms and graphene. And what happens is when you shine a laser light on a highly ordered graphite, which has no defects at all, it has amazing thermal conductivity in the layers, but has very poor thermal conductivity or relatively poor thermal conductivity across the layers. And so, you can see that just how the atomic layers are arranged. This is like a 1 centimeter cube piece, but down to the individual atom, which is like a 10 to the -9, you can see that by shining a little bit of laser light, it gets really hot on the sides. Why? Because it's conducting heat very efficiently in plane, but across the layers, it's cold as room temperature. So if you touch the sides, you'll get burnt, but if you touch the top and bottom, it's as cold as room temperature, and you'll be fine, right? So this is a pretty cool manifestation of what we can do by atomic scale and nanoscale manipulation of materials. The other work that I do in my lab is got to do with composites. So we make polymer composites. Why polymer? They're some of the lightest materials out there. They're not the strongest. So the idea is by using composites, including with new materials such as graphenes or carbon nanotubes, we can improve their properties. Moreover, we can also find new properties, right? So we make surfaces in our lab out of rubber that are very prickly. And the part of our research was to investigate slip-resistant materials. So such surfaces can be really awesome for walking on ice, right? So they can achieve very high inclines on wet ice. And this is just some prototype materials similar to ours, which are being tested. So you look at the power of again microscopic manipulations of material, and what kind of macroscopic and mechanical effects you can have, right? This is a whole field of ice tribology and a major area of research in mechanical engineering. Why do I do what I do? Well, it's just because of this. I really love sci-fi. I'm always rooting for the superheroes that are using technology rather than some mystical superpowers. So Iron Man is one, Batman is one, right? So this is sort of like things that really motivate me, in sort of innovation and design, right? So that's just a little bit about me and my research. I think, yeah, the idea is how to make this now a reality. Thank you.
All right, thank you so much. So now, since we're still recording, we're gonna have the closed Q&A in this session. The co-op panel and the research panel are gonna ask some questions directed towards the professors. You can still you can still submit your questions with my colleague Hashir. He will call your name out during the open Q&A session. So from the co-op panel, we have Braden, we have, sorry, I've lost the names. We have Braden, we have Joanna, we have, sorry, let me just bring up the list. We have Joanna, we have Ken, and we have Melina. And from the research panel, we have Daniel Dromsing. So they will be asking some questions from the professors. All right, Braden, would you like to start?
Sorry, is this my presentation or do you want me to ask
No, the
some
Q&A with
questions?
the professors. Yes.
Okay. Can I pick anyone?
It can be directed towards all of them or a specific question. But don't ask about your grades. So that's all we ask.
Luckily, I don't have any well, I guess Hossam is actually kind of my professor, so I got to be nice to him still.
Yeah, remember this. I'm still marking your capstone, so remember this.
Yeah, exactly. So, I mean, I guess a lot of you have taught in multiple different schools and settings. What makes York and Lassonde special? So that's an open question to any one of you.
Can I start? I think the fact that it's new, that's the nature of, if you compare the York University of Lassonde to any other institution around, which have been established for years and years, do innovation in teaching and learning in labs is very, very hard because faculty members get used to a certain way of doing things, certain way of teaching. They get comfortable with certain labs and methodology of teaching and pedagogies. So when Lassonde is only 5 or 6 years old, and so we started with fresh ideas. We started with trying to be as innovative as possible, trying to get the students engaged as much as we can. And because it's a small university, the connections, at least that's what I think, the relationship between faculty members and students are a very close relationship. We're always communicating with our students on a daily basis. There is not this barrier that you might see in other institutions between faculty members from one side and the students on the other side. This would be the first thing that I will, from top of my head.
And I guess the other.
Go ahead.
Sorry, Reza. Yeah, I guess the other thing I was going to say is just that we're fairly new and young departments. So if you look at, like, for instance, when each of the professors finished their PhDs, like Reza finished in 2014, I finished my PhD in 2016. So we've really only been professors for a short amount of time now, and so we're bringing kind of the newest ideas, the newest research, the newest kind of ways of teaching as well. So there's a lot of youth and kind of enthusiasm. We're not like a bunch of old professors who just want to, just do our lectures and then go home. We're actively kind of having fun doing this stuff and enjoying it somewhat. And I see Roger's laughing a little bit, so he's
at the risk of sounding ageist,
No, but
no, the department, it is a young department in more ways than one, and I think that is an important aspect of it.
Yeah, and I don't mean by age. It's just, but like the ideas that are coming out of the department. So go ahead, Reza. Sorry, I cut you off.
No worries. Yeah, I just wanted to add to what Hossam was saying too. Like the fact that we are willing to try and we're willing to explore other options is great, right? My previous background, I was a professor at University of Toledo in Ohio. They had a legacy program of mechanical engineering that went back to 1920s, right? And as a young professor there too, like just getting them to do anything and move the needle like a bit forward was impossible, right? It was always like, let's put a pin on it or something like that. Nobody wanted to change anything, right? Like if it's running, it's just running, it's okay, right? But the fact here, like in the last year or two, just seeing that, like my courses that I'm teaching, they have like now Discord channels, right? Like Discord servers. Like I would have never ever imagined that at my previous institution, right? Like I don't even know, like, so this is like a very important I guess aspect that we got to own up to. The other thing that I also like about the the novel element, or the being new, is that we have a very important emphasis on soft skills in our programs. Compared to a lot of other schools, right? Like, so about the BEST program, and about all of these courses that you're being asked to take, the design courses, etc. They're training you in these soft skills, which really at the end of the day, they're just as important for professionally as the technical skills you're learning. And that I also saw lacking in my other university.
All right, so we're gonna move on to the next question. Joanna has a question.
So my question was, I guess all the professors had different backgrounds that got them to where they are today. Sorry, it's really loud outside. And my question is, what do you advise first year students that may be struggling with knowing what they want to do moving forward, or if you ever felt you got to a position where you weren't sure what you wanted to do next, and maybe one advice of what you did to kind of figure out your way to either Lassonde or to where you are today?
I think my biggest advice is you just never know where you're going to end up. I did not think I would be living in Toronto. I was swore I would not live in Toronto, being a Westerner. And so one of the things that I think really is, just taking your experiences and seeing kind of how they lead you. You'll be surprised where you end up. I always thought, mechanical engineering degree would be all I would do. I didn't consider doing graduate studies. I didn't consider all the other opportunities that come up. So even like regardless of what you do like over your career, like there's going to be a lot of these opportunities that really kind of open doors for you. So it's really just I think be willing to learn and willing to take a risk here and there is the main thing that I would say for anybody. And this goes beyond schooling in general. Is really I think an important aspect of things.
Yeah, I would echo that. I think the adaptability is something that's really key. And I think that mechanical engineering, I think Riza was saying this is, like there's a certain inherent adaptability to the skills you learn as a mechanical engineer too, in terms of its cross-discipline, sort of cross-industry application and things like that.
I just want to add that, to Garrett and Roger is just basically repeat what they said about don't stress yourself about your career. You didn't plan your career 10 years ahead of time. Some people know exactly what they want to do from first year. Some people don't, which is okay and it's normal and it doesn't affect your career in any way. Take your time. Enjoy what you're doing in first year. Try to investigate and get engaged, as Braden said. Try to get engaged with different society, different community, until you know what your passion is. Don't stress yourself. Okay, I don't know what I'm doing next year or what I want department, and I'm failing or I'm losing my path. No, you have all the time in the world. People change their mind from year to year, change their interest from year to year. So I would say if you don't stress yourself about this, relax, enjoy your time, enjoy what you're doing. If you don't like it, look for something else that you enjoy to do until you find your passion. That would be my advice.
We have another question. It's actually from me. So how did you choose your specialty within mechanical engineering? Because you've mentioned that mechanical engineering has a lot of branches and there's basically nothing that is, as Braden said, that is untouched by a mechanical engineer if it moves. So how did you choose your specialty and what made you make sure that this was the right path for you?
I got good marks. So in my undergrad, it was the thermofluid field, which are they all connected, and there is the material field, kind of. I mean, it's very, very broad in undergrad, but and manufacturing. And I was. It's just you go into class and you enjoy more and you feel you have more passion and it's easy to understand. If I have free time, I'm going to spend it in my thermofluid course than spend it in a material course. So, and that's the importance of you change. You try your second year, you're forced to take some courses. You're going to find your passion. Okay, I like this course. I like the materials, and by after the end of the year, you figure out, okay, this is a field or this is the topic that I like more than other courses. Yeah, that's what happened to me at least.
I think for myself, I think I echo sort of what Braden was saying earlier on. I think I was really fascinated by, cars and machinery, and I grew up on a farm and things like this. So it was always really kind of this tangible moving parts and machinery that I really liked. And I never actually thought that I'd get into the thermal fluids or heat transfer aspect of it myself until I was, much later in undergraduate and that sort of thing. So I think I think lots of different things can attract you to it for different reasons. I think until you kind of roll up your sleeves and start doing some work in it in these different courses, you quickly get a sense of what you like and what you don't like. The other thing too is that I should be, like we should, this is it. I think you can wade in, and I think we shouldn't be afraid to say that if it doesn't suit you either. I mean, you can make changes, right? So, and that's important to point out as well.
All right, thank you so much. So now we're going to start our co-op panel presentations. So I believe the first presenter is going to be Joanna. Joanna, if you're ready, let me know so we can get started.
Sorry, who was the first presenter? I missed what you said.
You're going to be the first presenter for the co-op panel, yes.
Okay, perfect. Just give me a second. Awesome. So my name is Joanna Bergen, and I'm a fourth-year mechanical engineering student. I started my mechanical engineering undergraduate experience at a different university, but 2 years in, I decided to switch to Lassonde, and I am still doing mechanical engineering. And by far, I think it's the best decision that I've made. What I love about the mechanical department at Lassonde is that they truly care about your learning experience, and they always make time to listen and help you with any challenges you're facing. So now I'm in my last year, and I'm here to share with you one of my co-op experiences. The first internship I got was at an automation company, and my position was a mechanical and student intern. So the company had a warehouse with a bunch of robotic cells that machined and welded car parts together. And my job was to use the Inventor software, which is very similar to SolidWorks, to design some parts for the warehouse. When I started the position, I was really nervous because I didn't know what Inventor was and how to use it. So I decided to dedicate the first 2 weeks into watching a bunch of YouTube videos. And the Eng 1102 and Mechanical 2401 courses both helped having the SolidWorks background with learning Inventor. And I also had another employee with me who was kind of guiding me the first 2 weeks, and I foreshadowed his work and he showed me everything. The best part of the job is I was actually able to work with different departments. So I went to the warehouse and worked with machinists to measure parts, and then I went upstairs and designed it. And I think through this work, it helped me realize that I actually love the process of seeing a project develop from scratch. And I want to share with you guys something. I have a picture of the first time I designed a part. I'm able to share my screen, perfect. So this is the first, can you guys see it? My screen is, okay. So this was the first thing I ever did for the company. And you can see here, it says drawn by Joanna, and this is a design that I made. And then after that, I went down to the warehouse and I was actually able to see it being developed in front of me. And looking at it, I saw the paper and it was my name as well. So knowing that I was part of creating something that helped, keep the company going was really great. And I guess from there, I wanted to share with you a few things. Is some of the courses that you learn will teach you how to do risk management and progress analysis. And I've sort of applied that to my own life and skills. So I decided this was in my third year, I decided to build what I call my tree branch. On the right side, I put everything that I enjoyed doing, that I was good at doing through my co-ops. And on the left side, I put the things that I wasn't good at and I struggled with and I couldn't see myself doing in the future. So with this internship, I loved seeing a project develop from scratch. I also knew that I was really interested in doing SolidWorks, and I wouldn't mind doing full-time work with SolidWorks. I knew that coding wasn't my best aspect, but this really helped me, and I would recommend it for you guys while you're doing your co-ops and your courses at Lassonde to see what you're good at, and this will help you really figure out what you want to do post-graduation. And that is it for my presentation. If you guys have any questions, I think there's a Q&A session after that.
All right, thank you so much. Next up, we have Ken, who's going to talk about his co-op. Would you need screen share or?
Yes, please. Yeah.
All right.
There are actually two of me in the participants list. I think you need to give the permission to the other one.
Both are good to go.
Okay. Okay. So hello, everyone. I'm John. I'm an international student, and I'm in my final year of the program. And yeah, I will talk a bit about my co-op experiences. So for my first co-op term, I worked with Dr. Melenka in his lab, conducted some research on composite materials. As he briefly mentioned, these are very promising materials for the future because of their lightweight and they're highly customizable. But and Dr. Melenka works on a specific sort of them, mostly on braided composites, and there's still some work needs to be done in order to better characterize them and understand their strength before we can apply them. So my specific project was about testing them under bending loads, which is something we learn in the mechanics of materials course. So I really had the opportunity to use the theoretical information and kind of apply it in experiments. Doing the experiments, I used some optical measurement techniques, which was a nice addition to the curriculum. This is not something we learn. So research really gives you the opportunity to extend your in-class knowledge with some advanced techniques. This gave me, doing the experiments, I had the chance to design them myself, and this involved designing a lot of custom parts. I used the CAD software, did a bit of drafting, really all practical stuff in combination with some theoretical knowledge. And in the end of the summer, I had the opportunity to present this. And eventually, during my third year, actually, after my third year, we published my summer research. So research really is a great way to get involved in addition to student clubs. You can, early on in your undergraduate career, you can start to find your specialization and think about what you want to do in the future. But so this was my first co-op. For my second one, I changed things up a little bit, and I went to Switzerland for a year to work in the compressor aerodynamics department of an energy company called Ansaldo. They also make gas turbines, and gas turbines is something we study very well in our thermodynamics courses with their overall aspects. But you get so used to drawing these diagrams and drawing these trapezoids. I was working only on the compressor portion, and gas turbines are, you can think of them as jet engines, but instead of being mounted under a wing, fixed to the ground, and they are used to produce energy, electricity for cities or custom environments. We actually have a smaller gas turbine in our campus, and in the thermofluids lab course, you actually have a chance to visit that place. So as a part of my role in the compressor aerodynamics team, when I joined, the gas turbine was already designed and they were at the testing stage before it was released to the customers. So my role was mainly about determining the performance. I conducted performance analysis, tried to determine performance issues, see where the problems were located. And this, the reason I loved doing this was this monstrous machine. Really, what it all comes down to is real core concepts we learn in our fluids and thermodynamics courses. And these are really used to manipulate the flow to create energies. And I think it's just beautiful to combine all this piece of knowledge in real mechanical hardware to produce usable energy. So I really enjoyed this. And during the testing stage, what we did was use data from really complicated testing with rig with 6,000 sensors or something. And in order to make sense of all this huge amounts of information, I had to use knowledge from instrumentation and heat transfer courses as well. I also had the opportunity to do a little bit of programming, develop some custom software, and in the end, all these complicated efforts get converted into what we call a compressor map. This is what the customer looks in the end before making the decision to buy one of these huge machines. So all this knowledge really translates nicely into a simple, nice figure. But the process behind it, I find it very inspiring, and it's a real good application of all the theoretical knowledge you gain in the courses. So after I enjoyed my role so much, for my final year, for my fourth year, I decided to continue doing research while continuing my studies. And this time I'm working with Dr. Kempers in his lab, and we are looking at thermosiphons for electronics cooling. This is, again, a very applied usage of the theoretical knowledge you gain, and it has the potential to become a very common solution in the future. So being involved in research really gives you the chance to say, like, you were there since the beginning and you contributed to this technology developed. So I would highly recommend it. And in closing, perhaps what I want to say is, as an undergraduate student, you are in a unique position. You can do, my recommendation is, do separate co-op terms instead of doing all 16 months in a single place, and perhaps explore different industries, because switching industries drastically is harder in your further future career. But as an undergraduate student, no one will question you. So in my first year, first co-op, I went with something in the material science domain. But then later on, I went to turbo machinery without knowing much about it. I enjoyed it so much, and I decided to continue doing thermofluids in my final year. And perhaps for the future, and now I'm considering pursuing graduate studies in thermofluids area as well, or perhaps move into industry surrounding the thermofluids field. Yeah, so that's kind of that's what I wanted to talk about. I really recommend making use of the co-op program. It's a wonderful opportunity to use all the knowledge, and yeah, I hope you choose mechanical, and I wish you success and all the best in the program. Thank you.
All right, thank you so much, Ken. So up next, we have Melina with her presentation. Melina, would you need screen share?
Yes, please. Hi, everyone. My name is Melina, and I'm in my final year of mechanical engineering at Lausanne, and currently I'm a research assistant for LEIS. And in the past, I've completed 2 work terms through the Lausanne Co-op program. So why did I choose mechanical? Well, when I was in my first year, I wasn't sure what type of engineering I wanted to pursue, but all I knew was that I wanted to gain a wide range of skills and get exposed to as many industries as possible in order to figure out what kind of job I want to do. And like I decided to go into Mech because, as other professors also mentioned, it's a jack of all trades. So you get exposed to a wide range of skills and you can choose which ones you want to master. So during my first co-op, I worked as a process engineer for Cosmetical Laboratories. And Cosmetical Laboratories is a third-party manufacturing company of luxury cosmetics. So during this job, I designed and performed experiments to collect rheological data, which is basically how fluids flow, and collect those fluid dynamics data on the products in order to analyze the data and create new methodologies for manufacturing with the goal of improving the product quality. And after I did all that, I had to create technical reports, manufacturing procedures, which were followed to manufacture products, which, for example, one of them ended up with 500 kilograms of mascara being manufactured, which, if you know mascara, you know that's a lot. After showing my capabilities with this project, I got the chance to do some side projects.
So one thing to consider is that this position was specifically catered towards a chemical engineering student. But as I mentioned in the last slide, the mechanical engineering program gave me the skills in order to succeed in this position. Those include fluid dynamics, thermodynamics, and even stats, which is a general course. And also, we have a lot of design projects that are really helpful, specifically with their technical reports. Like we learn a lot about how to write like a proper technical report, and also do a lot of presentations. And of course, at this co-op, at times I was very frustrated, and because I had to learn a lot of new skills that like I wasn't aware of. But that's kind of the best part about doing a co-op. You always learn new things, and everyone's always willing to help. So here's a short clip of this machinery called a rheometer, and it basically squeezes the mascara in order to get data on how this mascara is deforming. And this helps with figuring out like what the issue is, and making sure the product is as what the customer wants. So during my next work term, I worked as a work management intern for Ontario Power Generations. And during this 8 month, I got the chance to oversee the refurbishment project for the nuclear power plant, and to be a part of the completion of this refurbishment. I was tasked to organize and chair the meetings and get updates from representatives and assign tasks to make sure the project is being executed smoothly. Um, I also assisted the project managers with scheduling their projects. Honestly, at the beginning, when I started this position, I was giving the tasks that were like very easy, and like I wasn't that keen to do them, but I still did them. And through completing more work and asking for more work, I kind of gained the trust of the team, and I started getting my own responsibilities. And I was very busy at that, like during that work term after. So the courses that kind of helped me a lot in this position also includes fluid dynamics, thermodynamics, all the all those courses that you learn a lot about in mechanical, because they help me realize and learn how the nuclear power plant actually operates. And using that skill, I would be able to realize if there's a scheduling conflict, or if tasks weren't supposed to be done before one another. Additionally, like you also take Eng core courses that teach you things about Gantt charts, and those are really important for project management if you're looking into pursuing that field. So that is my presentation for today. Let me know if you have any questions. Thank you.
All right, thank you so much. Up next, we have Braden with his presentation. Braden.
Do you mind giving me a screen share again?
All right, you got it.
Let's see. It's hard to be a professor. I feel bad for giving Hussam such harsh feedback on anonymously. So can't see, it's in the way. So I'm Braden. I am sure you heard me talk at the beginning. You're probably sick of it by now, but now I'm going to tell you a little bit about my co-op experience. So I guess before I get into that, a little bit more about me. Like I said, I was part of the first mechanical engineering class here at York. I've done the BEST program. I have 16 months of co-op experience. I was never actually enrolled in the co-op program. So everything I did was sort of on my own. And I have accepted a job offer from one of my co-ops. So it's definitely worth looking into. So I've done 12 months at the same company, HTS Engineering, in 2 different departments there, and then another 4 months at Exco Engineering. So at HTS, I dealt with commercial HVAC sales. So this was a interesting position. It really blends, the need for soft skills, like Reza had mentioned. I'd say they're almost more important than some of the technical skills you learn. but you need to have both. So it's really important. So one project I worked on was the subway station at York, which is pictured here. So for that, we supplied custom air handling units and some split systems. So I would work with consulting engineers and manufacturers basically to figure out what equipment was needed and select it and design it. And also a lot of my time was spent comparing different alternatives. There's never just one way to solve a problem. So that consisted of doing cost and energy analysis. So a few relevant courses I had, engineering communication was big. I mean, like I said, it's paramount that you can communicate your ideas. Thermodynamics and the engineering projects course, especially the economics portion of it, because it's a very business related job, it's important to figure that out. So a few useful skills from that. Again, communication is key. Organization and time management. You don't have a professor telling you, reminding you that you got to meet your deadlines. It's up to you to figure that out. And if you miss a deadline, well, good luck, because there's no forgiveness. There's no 5% late penalty. So you really got to get that down. And a good understanding of heat transfer and thermodynamics was also really important. And like I mentioned, the business. And then I transitioned into the contracting side. So this was more of a project management role. So I did engineering takeoffs. So basically I'd go through the drawings and specifications of new construction, figure out what mechanical equipment was there, what we'd be bidding on, and create a bill of materials. And a lot of these jobs were, had bids exceeding $1 million. So they're all quite large jobs. Again, a lot of the same courses. The mini design project was really key. It's really your first sort of taste of what being an engineer is like, and getting to figure out how to work out all those details. In this, I mean, because of the budgets you're working with, attention to detail was huge. You don't want to miss a piece of equipment that's a $500,000 chiller, and it's not included in your bid. And now you got some explaining to do, and your company's not going to be too happy. And then moving on to Exco. So this is the automotive manufacturing. So here I am standing beside the ejector half of a Ford transfer case die. So I helped on this design, and I created the engineering manuals for this. So basically, I had to break it down in it's kind of like a Lego instruction manual of how to put it together, which sounds kind of funny, but normally we would send people to the factory to go help them assemble it, but because of COVID, we couldn't do that. So it was really important to capture all the details on how this went together. I mean, there was hundreds and hundreds of pieces. So that was one thing I did. And I also got to work on die design, especially the cooling systems for the dies, which was very interesting. And so a lot of my job was working with CAD software and creating drawings to be manufactured. So this die in total, with the cover half that's not shown, was 90,000 pounds. So I mean, that gives you an idea of the scale, what you're dealing with. So for this, it was a little different. The CAD course was really key. You learned SolidWorks. We didn't use SolidWorks, we used Siemens NX, which is laid out very similar to SolidWorks. But the key there, I think, was the concepts I learned in SolidWorks, and they were transferable to these other softwares. So it doesn't really matter what software you learn. It's more about learning how the models go together, how you want to go about modeling these complex shapes and designs. The manufacturing course taught me a lot about die cast, which was part of the reason I got that job. Definitely. And again, communication. So the skills, a lot of the CAD stuff was really important in the drawings, and just understanding how we were actually manufacturing these things. So yeah, that's all that I have. If you have any other questions that you think of, I think we'll have a question and answer period after this, but if there's anything you forget, you can reach out to me on LinkedIn, and I'll be more than happy to talk about it. So thanks.
All right, thank you so much. So we're going to start the recording now, but before we do that, I just would like to thank all the faculty members who attended. I also like to thank all the co-op panelists, and I would also like to thank Professor Paul O'Brien, who helped coordinate this event. I would also like to thank LES for all the effort. The academic committee and the event committee helped a lot with this event, and my colleagues Jatin, Saeed, Hashir, Vincent, and Ethan are now here, and I would like to thank them all for letting us set up this event. All right, Hashir is gonna stop the recording now.